Welcome to another video lecture series on digital electronics. In this video, we'll be seeing the basics of module 4, which is elements of a sequential circuit. So from module 1 to 3, it was all about combinational circuits, and from module 4 to 6, it is about sequential circuits. So what are these sequential circuits? As the name indicates, these circuits run in a sequence. So many digital applications require the output to be generated in accordance with the sequence in which the input signals are received. So the best example for this is a counter. So counter counts 1 for the very first time. For the second time, it counts 2, which means it already had an input 1 to which we are adding a new input to get 2. So this means that there has to be some memory element which stores the previous one. For the next time it will store 2, and I give one more clock pulse, it will increment it to 3, right? So this means that the output is generated in accordance with the sequence in which the input signals are received. The output is not only dependent on the present input, but it is also dependent on the past history. So initially you had 1 saved, and that is why for the new count you have now incremented value by 2. So past history of the input is also considered here. How is this past history provided? Of course by feedback, right? So say counter is something like this. Initially it is 0. I give 1 clock pulse. It increments the count to 1. I have an output 1. This 1 goes as a feedback here, which means it goes and gets stored here. I give another clock pulse. It increments this 1 to 2 now. So this gets incremented to 2. I receive 2 at the output. 2 goes again as a feedback. I gave a new clock pulse. Now it counts to 3, and so on and so forth. So this feedback is very, very important. From the output back to the input. So the basic element is a memory cell which should save or store 1 bit of the memory, right? So this is a very basic memory cell which I have drawn here, which has 2 NAND gate and connected in cross coupled connection. Inverter means what? NAND gate here is working as an inverter, as a NOT gate. So how does this work? See, initially when I switch on the circuit at any random state, the output of Q is 1. This 1 in a feedback, I will use a different color. This 1 in a feedback to this NAND gate. Now remember, NAND gate is a 2 input gate, right? So since I am putting 1 here, it is understood that the second input is short here by default, right? So this 1 goes here. 1 into 1, NAND does multiply and reverse of it. So 1 into 1 is 1, and NAND will give 0. So output that I receive at Q bar is nothing but 0. Now this 0 goes as a feedback to this G1 NAND gate. So again you have 2 input NAND gate here. 0 into 0 is 0, but 0's complement NAND will give you 1. So my Q is 1 here. Now this keeps on going, which means the state of Q is always 1 and state of Q bar is always 0. Which means this setup is saving or storing 1 bit of memory, which is 1. Please don't get confused कि either 1 है either 0 है, which means it is saving 2 bits. No, that's not correct. It is only saving 1 bit, which is Q. Q bar is just the complement of the Q which you are getting here. So in short, this is storing 1 bit of information, right? Had this been reverse, which is also possible, which means I will quickly draw here. At the start, itself, say my Q was 0. When I switch on the power, my Q is 0. This 0 travels back as a feedback to this NAND gate, and NAND does 0 into 0 0 and reverse, which means 1. So Q bar is 1. This 1 travels back to the first gate here. 1 into 1 is 1 and bar will and NOT gate will give you 0 for Q. So Q here is 0, which means this setup remains as it is throughout. So here this latch, this is also called as a latch, 1 bit memory cell or a latch. This latch saves the value of 0. This latch saves the value of 1. So this is what is the meaning of a 1 bit memory element or a 1 bit cell, which is the basic element of any sequential circuit. So this is a latch. Slowly, steadily we will develop the concept of a flip-flop. Now in this latch, there is no provision for us to give any external inputs, right? So this NAND gate is short here, 2 inputs. This is also short here. We're not showing it, but by default it means it is short here. And you have this cross-coupled connection. There is no means in which you can add your input to it. And hence, because it's not necessary that when I switch on the circuit my value will be 1, or when I switch on the circuit my value will be 0. It is my choice as a user to use this memory element to either save it as a 1 or save it as a 0. So I should have that choice to enter my input data, which I am not having here. But still this is an example of storing a memory, of saving 1 bit of information. Since we are able to store, now I will use my inputs to store that kind of a data. So for that I have to make minor modifications in the circuit, and the new circuit looks something like this. So this is called as the memory cell with provision for entering data. So this is your NAND gate. I will name this as G3, G4. These are the same NAND gates which we have used as a latch. So I will have cross connections like this. This is exactly same as what you had previously, but now I am using the second input, this input, to enter the data that I want, right? So this is my G1, this is my G2, this is my Q, and this is always Q bar. Please remember, it is not storing 2 bit of information. It is only Q that it is getting stored, but Q bar is a complementary information that you are getting here. So now since we have 2 provisions of input that I can send here, which is first to G3 and to G4, how many combinations can I give as input here? I can have 4 different combinations. So my input could be 0 0, both 0 0, or it could be 0 1, or it could be 1 0, or it could be 1 1, right? So I will stop the video here. In the next video we will start from this memory cell with the provision of entering the data and see how it is storing various informations. Thank you for watching.